Hi everyone. In today's video, we are going to discuss few fundamental properties of the topic of reflection from the chapter ray optics. Okay, so this is a mixture of what is given in your NCRT and few additional things which you need to know. Okay, from point of view of various entrance examination. Now, first is with regard to the properties of light. Properties of light. Okay. Now, in this chapter, when we say light, we are talking about the part of the electromagnetic spectrum which we can see. That is, light means the visible light. Visible light. Okay. So when we say visible light, so that means we are talking about the wavelength. So the wavelength range for this for visible light it is from around 400 nanometer to 750 nanometer. So wavelength range from 450 nanometer to 750 nanometer is the visible range. Okay. Then second important feature of this light is its speed in free space. It is denoted by the symbol c, and it is equal to 3 into 10 power 8 meter per second. So this is the speed of light in free space. Okay. Now coming to the topic of reflection. So this reflection, it is of two types. Reflection, it is of two types. Uh, One is the regular reflection. Regular reflection. So regular reflection means the reflection that takes place in a mirror. Okay, say plane mirror. So this is the direction of the incident ray. Incident ray is coming from this direction, and then this is the reflected ray. Okay, so in regular reflection, we can see the image. Okay, image is formed. Okay, but see, light is also reflected from this paper. Okay, so but light is reflected from this paper, but we can't see our image on the paper. Similarly, light is also reflected from the wall, but can we see our image on the wall? We can't see. So there also reflection is taking place, but we are not able to see the image because that reflection is called diffused reflection. Diffused reflection. Why we are not able to see the image? Because for such, say, wall or this uh, paper, the surface is not smooth. Okay, so surface is like this. If you see the surface in macroscopic level, microscopic level, the surface is not smooth. So obviously the light, suppose light is coming in this direction. This is the direction of the incident beam. So depending upon the orientation of the surface, the reflected light, it will go in different directions. Okay, so as a result, the reflection is said to be diffused reflection. So it is not in a particular direction. Regular reflection means it is in a particular direction or a coherent direction. Okay, so that is why in diffuse reflection, if somebody asks you why we are not able to see our image on a say wall or other such objects where reflection is taking place, then you have to say the answer is because it is because of diffused reflection. Okay, it is because of diffused reflection. Acha. Now there are two fundamental laws of reflection. Laws of reflection. See, suppose this is the mirror, this is the polished surface. So incident ray is coming from this side. This is the incident ray, and this is the reflected ray. Okay, and suppose this is the normal. This is the normal. This is the incident ray. This is the reflected ray. This is angle of incidence. So angle of incidence is the angle between the incident ray and the normal. Okay, and this is angle of reflection. So angle of reflection is the angle between the reflected ray and the normal. Okay, so the laws of reflection, the first law says that the incident ray, this is the incident ray. So the incident ray, the reflected ray and the normal at the point of incidence, they lie in the same plane. They lie in the same plane. Okay, so we can also say that incident ray incident ray incident ray, reflected ray, and normal at the point of incidence are coplanar coplanar. Okay, coplanar means they lie in same plane, lie in the same plane. Okay, now this is the first law. But what is the mathematical implication of this? Mathematical implication of this is, suppose I vector, this is the incident ray, this is normal ray, direction of the normal ray, and this is R, the reflected ray. So these are the vector representation of incident ray, normal ray, and reflected ray. Now they are coplanar. They are coplanar. Okay, so they are coplanar means the vector coplanar vectors. What is the property of coplanar vectors? We can write R dot I cross n. Scalar dot product will be 0. So this will be scalar dot product of all these three quantities. So I can, and this is also equal to n dot I cross R. So this is also equal to I dot n cross R. So all these quantities will be equal to 0. Okay. So this is because these three vectors I, n, and R are coplanar. Okay. So this is first law, and this is the implication of the first law. Okay. Now second law says that the angle of incidence is equal to angle of reflection. Angle of incidence is equal to angle of reflection. Okay. Acha. Now there are certain special cases like special cases. One, when we have normal incidence. Normal incidence. That means if this is the mirror, okay, and suppose this mirror is polished, so this is the polished surface, okay, and the rays incident in the normal direction. Okay. So obviously in this case, angle of incidence will be equal to 0. Okay. So reflected ray will retrace the path. Okay. So this is I, this is R. So reflected ray will retrace the path. It will go along the same path. So here, angle of reflection will also be equal to 0. Angle of reflection will also be equal to 0. Okay. Acha. This is for normal incidence. Then another case, grazing incidence. Grazing incidence. Grazing incidence is when, uh, suppose this is the mirror, okay, and so this is the polished surface. Now, suppose the incident ray, it is coming like this. This is the incident ray, okay. So almost it grazes the surface, okay. So and then it is reflected. So again, it will go in this direction, almost along the surface, okay. And this is the normal. This is the normal. Okay, so this is the incident ray, this is the reflected ray, and this is normal. So this angle is almost, see, grazes the surface means it is almost equal to 90 degree, but it is not 90 degree, but nearly 90 degree. So that means this angle will also be nearly 90 degree. Okay, so grazing incidence means here angle of incidence will be equal to 90 degree, and angle of reflection will also be equal to 90 degree. Okay, so this is the meaning of this. See, these two things I have discussed so that we understand this term. What is the meaning of normal incidence and what is the meaning of grazing incidence? Okay. Acha. Now, moving further, next, let us understand. See, in a mirror, we whether it is a now we are discussing the case of plane mirror, but then we can have spherical mirrors, concave mirror, convex mirror. So there we will have an object, and for that object, an image will be formed. Okay. So what is the meaning of the object? Okay, how do you define an object? Object denoted by the symbol O. Okay, how do you define it? So let's understand it. Now, object is point of intersection of incident rays. Okay, so it is the point of intersection of incident rays. Okay, now let us take two cases. So we have a plane mirror. This is a plane mirror, and the object is in front of the mirror. Okay, so this is obviously object is front of the mirror means this is real object. Okay, so this is the real object, point object, real point object. Okay, so here from the object, this is the incident ray traveling towards the mirror. So this is the object. Okay, so here this is the point of intersection of the incident ray. Means incident ray is coming from this. So here it is intersecting. So here we have the real point object. Here we have the real point object. Okay. Another case, suppose we have this is a mirror. Okay. And this is the polished surface. Okay. Now, incident ray, suppose it is coming like this. Okay. So here, this is the incident ray. So this is the virtual side behind the mirror. And then It is going in this direction. So here the incident ray, here it appears to intersect at this particular point. Okay, it appears to intersect at this particular point. So now this is the object, but here it is actually intersecting. So therefore it is a real object. Well, here it appears to intersect. So here it is called virtual point object. Okay, so we can say that an object is called real if it lies on incident side. See here, this is the incident side. This is the incident side. Okay, so if it lies in the incident side, otherwise, see here the incident side is this one. Ray is coming in this direction. Okay, from this side is coming, but object is on the other side. Here the object is on the other side. So otherwise, it is called virtual. Okay, so this is for object. Okay, how about for image? Image I. Okay, so again let us draw a plane mirror. This is the plane mirror, polished surface. So here you have this is the incident ray. This is the incident ray. Okay, okay, here I did a mistake actually. See here this direction, the incident ray, it is going in this direction. Here this incident ray is going in this direction. Here incident ray is going in this direction, and then it appears to converge here. See here it appears to converge at this particular point. Okay, so here incident ray appears to converge. Okay, so that is why it is virtual point object. Okay, uh, here see incident ray is coming like this. So here we have the position of the object, but the ray will be reflected by the mirror, and here you will get the image. Okay, so here the image is the point of intersection of reflected ray. Okay, so image is the point of intersection of reflected rays. Okay, so here, say here the reflected rays are actually intersecting. So therefore, here this is called real image. Real image. So real image is formed in front of the mirror. Okay. Another case. This is the mirror. Okay. Object is at this particular location. So this is the incident ray. So it is getting reflected. So this is reflected. See here it is reflected. So here it cannot intersect. In this direction here it cannot intersect. Okay. So but here it appears. So if we produce it in the backward direction, it appears to intersect. Okay. Here the real, in this case, here the real image means reflected rays are actually intersecting. Here reflected rays appears to intersect at this particular location. Here the reflected rays appears to intersect at this particular location. Okay, so here is the image is virtual image. virtual image. So in a plane mirror, what we have observed is, see here also, uh, the object is here at this particular location. So image, it will be formed here. Okay, so both things can be explained in the single figure also. So what we have seen is, if object is real, okay, here object is real, in this case object is real, so image will be formed here, as in this case object is real, image is formed here, it is virtual. Okay, and if the object is virtual, okay, in this case object is virtual, here the object is virtual, in that case image will be real. Okay, so this is another important observation with regard to a plane mirror. So a plane mirror can form both real and virtual, both real and virtual images. Okay, both real and virtual images. Acha. Now, uh, next, let us understand a term associated with the reflection, that is called deviation. Deviation. Uh, suppose you have, suppose this is the plane mirror. Okay, and this is the incident light, incident ray. It is reflected in this direction. Okay, and this is the normal. So this is the actual direction of the incident ray. Okay, it is coming. It was coming in this direction, but because of this mirror, it is getting reflected in this direction. So this is the change in direction of the incident ray. Okay, it was going in the downward direction, and it gets turned, deviated through angle delta. Okay, delta is the angle of deviation. Delta, angle of deviation. So this is angle of incidence. This is angle of reflection. So obviously, as you can see, I plus R plus delta is equal to pi. Okay, but I and R, they are equal. Angle of incidence equal to angle of reflection. So I can write twice I plus delta is equal to pi, or I can write delta is equal to pi minus twice I. Delta is equal to pi minus twice I. Okay, so this is deviation uh, on one reflection. Okay, so this is, reflection is taking place once. Okay, so this is deviation with the one reflection. Deviation with one reflection. Okay, now let us see another case. Another case. Suppose you have two mirrors. Okay, and the mirrors are inclined at some angle. They are facing each other. Okay, they are inclined at angle theta. Okay, and this is the incident ray. Okay, it goes in this direction because of reflection, and then again there is a reflection, so it goes in this direction. Okay, now at first reflection, this angle is alpha, this angle is also alpha. Okay, so this was the original direction. So the deviation that is taking place at the first reflection is delta 1. Okay, now here in the second reflection, the ray was going in this direction. This is the normal. Suppose here this angle is beta. So this angle is also beta. And this angle of deviation at the second surface is delta 2. Okay, delta 2. Okay. So first case, first reflection, angle of incidence, angle of reflection alpha. Second reflection, angle of incidence, angle of reflection beta. Okay. So total deviation. Total deviation delta is equal to delta 1 plus delta 2. Okay. And what is delta 1? Delta 1 is equal to pi minus 2 alpha. Okay. Just now we have seen delta is equal to pi minus 2 times angle of incidence, isn't it? So delta 1 is equal to pi minus 2 alpha, and delta 2 is equal to pi minus 2 beta. Okay. So what is the, so if you substitute these two values over here, so what do we get? We get delta is equal to twice pi minus 2 times alpha plus beta. I have added these two. Okay. Acha. Now see, this is the normal. This is the normal. Okay. So, what can you say about this angle? This angle and this angle. See, this total angle, this angle is 90 degree. Correct? This angle is 90 degree. So, I can write this angle as pi by 2. Pi by 2 is the total angle. So, pi by 2 minus alpha. Okay. Similarly, I can write this angle as pi by 2 minus beta. Okay. Pi by 2 minus beta. So, I can write pi by 2 minus alpha plus pi by 2 minus beta plus theta is equal to sum of three angles in a triangle. It is equal to pi. So pi by 2 plus pi by 2 and this pi, they gets cancelled. Okay. Pi by 2 and pi. So that means alpha plus beta is equal to theta. Alpha plus beta is equal to theta. So I can write delta is equal to twice pi minus 2 times alpha plus beta is theta. Okay, so that gives total deviation is equal to twice pi minus 2 theta. So that means the deviation is independent of angle of incidence. It only depends on this angle theta. Okay, so this is an interesting result. Angle of deviation is independent of angle of incidence. So in whatever direction this incident ray comes, the total deviation it is going to suffer after two reflection. It only depends on this angle between the two plane mirrors, that is theta. Okay, so this is one very interesting result. Okay, so this is video is first part on the topic of reflection. Okay, these things what I have written, I will convert this in PDF and will share as the link in the description. Okay, so please go through this and practice these things with pen and paper on your own. Okay.